Hi, it's time for another math easy solution. Time to discuss further into trigonometric integrals and now look at the integral of sine squared of x and basically go over the proof video and show that the integral of sine squared of x dx is equal to 1/2 times x minus sine x cos x and plus a constant c. And now the proof of this one is going to be almost identical to the proof that I went over in my last video on integral of cosine squared of x, which was pretty much the same thing here, except instead of minus there's a positive. You add instead of subtract. So, and again, in the same thing as I did in my last video, basically what I did is I simplified this this trigonomic function by removing the squared from the sine squared of x, because whenever there's a squared or a power to a trig function, the integration just becomes more difficult. So we want to remove that, and one way we could do that is if we recall the half angle trig identity, which I covered in my earlier video, and you can see that in the video link below for the proof of it. And the half angle trig identity we're going to go over, the one we're going to use is basically sine squared of x equal 2, and this one is just 1 minus cosine 2 of x divided by 2, so all divided by 2, and this is a half angle because this angle x is half the angle of this 2x, so you could write it like this, and all we're doing is adding a 2x, which is better than having a power there. So when we use this identity, now we just try to integrate that instead. So what we now have is the integral of sine squared of x dx is equal to the integral, and then we'll just take the 1/2 out of there, so 1/2 integral 1 minus cosine 2 of x d of x. And now what we could do is easily integrate this, and this is just equal to, we'll take again 1/2 out of there. Integral of 1 is x. The integral of cosine 2 of x is going to be, well, sine 2 of x, and then we have to divide by 2 because of this 2 in there. When you use chain rule and take the derivative of sine 2 of x, this is going to be cosine 2 of x times 2, so you have to divide by 2 to get cosine 2 of x. So that's the integral like that, and then basically we have to add a constant c, like always when we ever do this indefinite integral. So this is pretty much the answer to this, but if we want to write it in the more common method of using this sine x cos x, where we don't deal with this double angle. So this, if you want to remove that too, and again, like my last video, you could basically use the other trig identity. So recall sine 2 of x is equal to just 2 times sine of x cos of x, and you can see the proof of this also in the video links below. So if we recall that and use that, we finally have integral of sine squared of x dx is equal to 1/2 x minus, and then the sine 2 of x becomes 2 sine x cos x, and the 2's cancel, and we're just left with sine x cos of x, and then plus a constant c, and there's basically our answer. So this was just pretty much a quick proof video, and that's just straightforward like that. Anyways, that's all for today. Hopefully you learned from this very quick video on trigonometric integration and how to use these trig identities to simplify this trig function and integrate it. Anyways, that's all for today. Like always, you can download these exact notes in the link below, and thanks for watching, and stay tuned for another math easy solution.